We're going to continue with chapter 1 review. In this case, we are in problem number 7. Problem number 7 says the graphs of f and g are shown. So we have these two graphs. Describe two different transformations from the graph of f to the graph of g. So I have my graph of f here. This is my graph of f. I can see, look at this point. I have -1. And I can see that the distance from this point to this point is 1, 2, 3, 4. There are 4 units up. 4 units up. And now from this same point, from F, if I go to the left, 1, 2, there are 2 units to the left. Now, how do we describe those ones? Okay. If we want to answer this question, how do we describe? So we're going to have, for example, this is an example that we can write. The graph of G is a vertical translation, is a vertical translation. 4 units up. Of the graph of f. Okay, that will cover going 4 units up. In other situation, I will just say the graph is just 4 units up of f, but this is more like the formal solution. Now I have the graph of g. In this case, is a horizontal translation, is a horizontal. Two units left of the graph of f, of the graph of f. Right? That's the formal solution to the problem. Now, problem number 8, what I have, let's look at this one. So I have a function g is a translation 4 units to the right. Okay, let me write this one. So I have number 8, 4 units to the right. Then I have 6 units down, 6 units down. And then followed by a reflection in the y-axis of the graph, reflection, y-axis. And the graph of this one. This is the graph that we're reflecting, and the graph is fx equals to -1/2 x plus 1 squared. Then it says graph f and g. That graph, you can do it on Desmos to save some time, don't make this video too long. You can just graph both on Desmos and you're going to see the transformations. So far, this is the information that I have, how I'm going to proceed with this problem. So remember, I want, in this case, the problem says a function g is a translation. So I'm going to start with gx. Gx is equals to, I'm going to have f of, if it says that it's a reflection in the y-axis, right? In the y-axis, I'm going to have negative x, and then it says 4 units to the right. So if it says 4 units to the right, look at this one. X is equals to 4 units to the right. So I'm going to have x minus 4 equals to 0. That reason why I'm going to use -4. Okay? We use the opposite sign when there is a horizontal translation. We use an opposite sign. So if it moves to the right, I'm going to use -4. If it moves to the left, I'm going to use the positive. Okay, negative x minus 4. And then how many units down? 6 minus 6 units that is going down. Now, let's simplify this one. Remember that the function is fx equals to -1/2 x plus 1 to the second power. Now what I'm going to have is, this is equals to -1/2. I'm going to open a parenthesis, having the x value, in this case, negative x minus 4 plus 1. See the plus 1 here? Plus 1 and all this one to the second power minus 6. What I'm doing is just pretty much a composition of a function. And now what I'm going to do is simplify a little bit. Negative 4 plus 1 is negative 3. So this is equals to negative 1/2 parentheses negative x minus 3 to the second power minus 6. Is there anything else to do? No. This is my g of x function. Negative 1/2 minus x minus 3 to the second power minus 6. So remember, first we describe the transformation formal. A reflection in the y-axis, then 4 units to the right, then 6 units down. And now what I'm going to do to find that function is use, because it says in the problem, it says followed by a reflection in the y-axis of the graph of fx equals to negative 1/2 x plus 1 to the second power. So then we do a composition of a function. So we take this x, negative x minus 4, plug it in the x here, plus 1 squared minus 6, and then we simplify. Now what you're going to do is just graph the fx and graph gx, and you're going to get your solution. Okay, problem number 9. Let's look at problem number 9. Okay, problem number 9 describes the transformation from the graph of f to the graph of g. See this one? This is the parent function. This graph here is the parent function. It's in 0, 0, 0, and I can see that goes through 1, 1, 2, 2, 3, 3. And then this graph moves 1 unit down and 2 units to the left. See, 1 unit down, 2 units to the left. Okay, so what we're going to do is this one, 1, 1, 1, 1. It goes through the square. So now what I'm going to do here is describe for number 9. What is number 9? The graph of g in this case. I'm going to move this one up so we can see it. Okay, the graph of g is a vertical translation, is a vertical translation, 1 unit down and a horizontal translation, two units left of the graph of f. Okay, that will be the solution for problem number 9. Let's look at problem number 10. So number 10, this is g, this is f. See, this is g, x, and this is f. So f, what can I see? Is move to the right 1 unit, 1, 0. And then is this parabola opens down. So that means is negative x squared. That's what I can see from this graph. And then the g graph opens up. That means it's positive. And then I can see that this one goes down 4 units. Goes down 4 units. There is no movement to the left or to the right. So what can I say about this function? This is going to be problem number 10. 10. Okay, so the graph of g this case is a reflection in the x-axis, is a reflection in the x-axis because it opens down. It opens down, so it's a reflection in the x-axis. A vertical translation. A vertical translation, 4 units down, this case, and a horizontal translation, 1 unit to the left of the graph of f. Okay, so from this graph, see, this is my f graph, this is g. So from this graph went 1 unit, okay, to the left, 4 units down. And the reflection here, remember that the f graph is opens down, so that means the g function opens up. So there is a reflection in the x-axis. That's the reflection. So that's problem number 10. Okay, let's move to problem number 11. Is a table. I have 11. The table shows the total distance traveled by a space probe after x seconds. What is the type of function can you use to model the data? Estimate the distance traveled by the space probe after 1 minute. So we have the time, distance, 0, 8, 20, 36, 50, 0, 76, 99, so on. Okay, that's the problem. Now I'm going to put some paper here to solve this problem. And what are we going to do? Okay, I'm going to find the slopes of these points. For example, 0, and I'm going to say y, right? 0 and 76, and I'm going to have 0 and 8. So m is equals to 76 minus 0 over 8 minus 0, which is 76 over 8. If we simplify, is 19 over 2, and if we divide, is in this case 9.5. Now let's see what's going on with the second one. M is equals to 190 minus 76. Now I'm going this way. 190 minus 76. And now I'm going 20 minus 8 over 20 minus 8. And this is equals to 114 over 12. And this, we simplify these two, is 9.5. We divide, like we're finding if these two are the same. And now we're going to move forward with 342 and 190, 36 and 20, 50 and 36, 475 and 40. So if we keep doing this one, we're going to find, I'm going to do this one last one. So I have 342 minus 190 over 36 minus 20, and this is equals to 152 over 16. Let's divide. If we divide these two, it's 9.5. So we continue, and the last slope is going to be 475 minus 40. This one minus this one. So what I have, 133 over 14, which is also 9.5. Now, as we can see, so in this case, as we can see, okay, there is a constant rate of change. So there is a linear function that starts with 0. So I can write this function as fx equals to 9.5x plus 0. That's my y-intercept. Start from 0, goes 9.5x, 9.5 as a slope, or you can write this one as fx equals to 9.5x. Now what I'm going to do, we're going to, the question is, table shows the distance by probe after x seconds. What type of function can be used to model data? Estimate the distance traveled with space probe by 1 minute. What is 1 minute? Remember that this one, the time is in seconds. So 1 minute is 60 seconds. So I'm going to have f of 60 is equals to 9.5 times 60. And what is that one equals to? 570. Okay, so what is my solution? I have after 1 minute, okay, so I'm going to have here after 1 minute, the space probe travel about 570 miles. Okay, that would be the solution. 570 miles is the solution to this problem.